All right, so let's put this to use. So in example 3, you roll a die. What is the probability you roll a 6? So I'm going to go up to our previous example because we already had our outcomes listed. So here are all of our outcomes. So we have 1, 2, 3, 4, 5, 6 possible outcomes. So that's always in your denominator. I'm going to use our notation, probability of rolling a 6. Well, there's 6 possible outcomes. And how many times do we see a 6 happening? Only once. So that's why it's going to be 1 out of 6. Now the probability of rolling a 3. Again, if I go back up to the visual, I only see it once. And again, there's a total of 6 outcomes. Oops. Be careful of that. Don't make that mistake. And then a probability of rolling a 2 is going to be the same, 1 out of 6. Now, for example 4, you toss a fair coin 3 times. What is the probability you get all tails? So I'm going to say probability of getting all tails. Well, lucky for us, we already listed this sample space in the previous example, which saves us time. We have 8 possible outcomes. How many times do you see tail, tail, tail? Only 1 time. So that's why this probability will be 1 out of 8. Now, pay attention to how my open math wants your answers. If they want a decimal, I'm going to go here to Google Sheets, whatever you like to use, or your calculator, whichever one. And I'm going to do equals 1 divided by 8. And it's 0.125. I'm going to bring this right here. Get rid of that. So this is 0.125. Again, it just is how the question is asked. You can see here clearly, though, that those values are less than 1, right? So we're on the right track. And if we wanted to change that into percentage, just to bring it back so you leave this class really knowing percentages, it'd be 12.5%. All depending on how the question wants it answered. Okay, so your next example. Suppose there are 12 blocks in a bag, and the blocks are identical except for their color. So there are 4 red blocks, 6 blue, and 2 yellow. So they gave us the total number. If they didn't, I would have just added 4 plus 6 plus 2, and I would have gotten 12. Now the probability of choosing a blue block, well, we know the total outcomes are 12. And how many options do we have to getting a blue block? It would be 4. Oh, no. No, it wouldn't. It would be, here's my blue, 6. I'm going to just highlight all of them. Okay, so it's going to be 6. So you can leave it like that. Again, you're going to pay attention to directions. And they might say, I want it as a reduced fraction, so that's why you would say 1/2. So whatever the question wants. B, what is the probability of a red block being chosen? Well, again, I have 12 possible outcomes, and there are 4 red blocks. All right, so then if I have to reduce that, that would become 1/3. C, what's the probability of choosing a yellow block? Again, total possible outcomes are 12. And yellow, we have 2 options. Again, if they want us to reduce, do so. If not, you can leave it as is. Now the last one, what is the probability of selecting an orange block? Well, when I read the problem, I don't see orange listed at all. We still have 12 blocks, but we have 0 ways of choosing orange. So that's why this is impossible to happen, so it would be 0. Now these are different colors, but remember they're identical in shape, so these are equally likely to happen, right? Because I'm just choosing in a bag and I'm not looking at them. Okay, we will pick up with complementary events in the next video.